Welcome to qnawire.
Have a monatomic gas that is going to be compressed adiabatically from an initial volume equal to 0.805 cubic meters to a final volume of 0.300 cubic meters. So remember that for adiabatic compressions, what is going to happen is that the factor PV to the gamma is going to stay constant, where gamma is going to be equal to the value of Cp divided by Cv. Recall that for a monatomic gas, we're going to have, employing the relationship of Cp minus Cv is equal to R, we're going to get, first of all, the value for Cp is going to be equal to 5 halves of R, and the value for Cv is going to be equal to 3 halves of R. This comes from the degrees of freedom that we're going to have on the single monatomic gas. So that means that the value for gamma is going to be equal to 5 halves of R over 3 halves of R, which is going to be equal to 5 over 3. So over here, what is going to happen is that in A, we want to know by what factor does pressure increases. And in part B, we want to know by what factor does temperature decreases. Another comment about this type of adiabatic processes, we can also express this relationship as saying that P to the 1 minus gamma times volume to the gamma, times temperature to the gamma, is going to be constant. So on the first part, for A, we're going to use the expression that I employed initially. So P1 volume 1 to the gamma is going to be equal to P2 B2 to the gamma. Thus, pressure 2, the final pressure, would be equal to B1 over B2 to the gamma times pressure 2, which is going to be, pressure 1 times pressure 1, which is going to be, in this case, B2 would be 0.3 and B1 would be 0.805. So this would be 0.3 over 0.805. Initial value would be 0.805 over 0.3, and all of this to the gamma factor that we just calculated. So this would give us 5.18, 526 times the pressure 1. This is going to be the factor that it is going to increase. So now, to know by what factor the temperature is going to increase, what we're going to get is that for part B, pressure to the 1 minus gamma times temperature to the gamma is going to be equal to pressure 2, 1 minus gamma, times temperature to the gamma. Thus, temperature 2 to the gamma would be equal to P1, 1 minus gamma, times T1 to the gamma over P2, 1 minus gamma. We can further reduce this expression as T2, which would be equal to P1, taking like 1 over gamma as exponential, 1 minus gamma over gamma times T1 over P2 to 1 minus gamma over gamma. So this is going to be the factor that we want to calculate, which is going to be equal to P1 over P2 to 1 minus gamma over gamma, T1. Since P2 is equal to 5.18, 1526 P1, the factor P1 over P2 is going to be equal to 1 over this number. Which is 0.193. So with this, T2 would be equal to 0.183 elevated to the 1 minus gamma over gamma. We can directly replace the value of 5/3 times T1, and the decrease of temperature becomes, in this case would be 0.183 to the minus 0.4 times T1, which is going to be a factor of increase of 1.930,977 times T1. So you can cut off the values up to the number of significant digits that you want. So these are going to be the answers. For some reason I wrote here decreases. It says increases in the question. Sorry about that. And with that, it would be all. Thank you very much and have a good one.